Hello. Now we're going to talk about converting between polar and rectangular or Cartesian coordinates. So sometimes we may be given something in terms of rectangular and it's easier for us to deal with it in polar. So we might need to manipulate it and turn it into polar coordinates, and vice versa. We could have something in polar and we may need to go back to rectangular coordinates. So let's define this. Essentially what we have is we've got our XY plane, right? So there's my Cartesian plane. And maybe we have some point. We'll call this point XY. So XY out here. X, I have a horizontal distance. Y, I have a vertical distance. And that X and Y, that allows me to make this right triangle. Okay, well, so now we're going to relate that. And we're going to say, well, instead of calling this point PXY, we're going to call it R theta. So theta is an angle rotation, and R is that hypotenuse. So if we have all of these values defined in this way, what kind of relationships do we already know? Well, we know that cosine of theta, if we identify that, that would be adjacent over hypotenuse. So x over r. We know that sine of theta would then be opposite over hypotenuse, y over r, and tangent theta is y over x. Now, especially with cosine and sine, we like to write these and say, well, if I multiply by r on both sides, I'll say that x equals r cosine theta, as well as y equals r sine of theta. So we don't really do that with tangent, but these two rearrangings that I did here, is that a word? These arrangements, they isolate, and we have x now in terms of polar and y in terms of polar. So these are really helpful formulas that we pretty much like to keep stored. And then the other really helpful formula we use is Pythagorean theorem. So r squared equals x squared plus y squared, or even just r equals the square root of x squared plus y squared. And we don't have to write the plus minus because in this situation we would be assuming we're measuring a positive distance. All right, so make sure you've got these down, specifically these three formulas, and let's work through an example. So for example, what we have here, we are going to convert this rectangular ordered pair, 2 root 3 comma negative 2. So we're going to convert this point in rectangular to polar. All right, so what do we have? Well, we have here, we've got x equals 2 root 3. And we also have that y equals negative 2. So we have identified our x and y, but we need to find r and theta. Remember, we know x is r cosine theta, y is r sine theta, and x squared plus y squared equals r squared. So that means r equals the square root of x squared plus y squared. And that calculation looks like r equals 2 root 3 squared plus negative 2 squared. And that is the square root of 4 times 3, 12, plus 4. R equals the square root of 16 or 4. So we know that 4 value. And then we have two ways that we can convert between these formulas, the x and y, to get my theta values. So I can use cosine and sine. And I could say that, well, cosine of theta is x, 2 root 3 over this 4. as well as the fact that sine theta is y negative 2 over 4. Simplifying both of those, I have that cosine theta is root 3 over 2, and sine theta is negative 1/2. So I know this ordered pair occurs on my circle, or my unit circle, at 30 degrees. Since sine is negative, I know that this is 30 degrees in quadrant 4, or 330 degrees. Theta equals 330 degrees. You could say negative 30 degrees if you wanted as well. Either of those work. You could list it in radians, pi over 6. That would be negative pi over 6 though, because we are, again, this is my 30-degree angle in quadrant 4. So lots of different ways that we could list this. 11 pi over 6. All of these coterminal angles represent theta. So my new ordered pair, which is the same, is going to be 4 and 330 degrees. So this is my polar r theta that takes me to that same ordered pair in rectangular. Now, we could have gone about finding theta a slightly different way. So I'm going to use my alternative method because remember, tangent theta is y over x. So that means tangent theta in this situation is negative 2 over 2 root 3, which is negative 1 over root 3, or negative root 3 over 3. So now we think about this. Where on the unit circle does tangent theta equal negative root 3 over 3? So we know that tangent theta is going to be root 3 over 3 at one of these 30-degree angles. And if we think about all students take calculus, we know that's going to be in quadrant 4 or quadrant 2. So that would either be 330 degrees or 150 degrees. And we would need to choose one of those. Now, the easiest way for us to think about this is to say, well, which quadrant does this point lie in? Positive x, negative y, it's in quadrant 4. So that would mean we would choose the 330 degrees, like we did right there. So one other thing I want us to do will be to write this polar coordinate with a negative radius. So we had 330 degrees. A negative radius would be negative 4. What would we have to use for our angle measure? We would need to subtract 180 degrees. Subtracting 180 degrees, that's going to give me 150 degrees. All right, so here is the same ordered pair, but with a negative radius. So those are the skills, or the tools, essentially these guys. All of these tools are the things we need to remember when we are converting between x and y versus r and theta. So again, these formulas that are all listed here, they're all things that we already have stored in our trig mind, in the folder in our head where we store all of our trig information. These are things that are just so basic to trig that we keep them stored. So we didn't really learn anything new. We're just thinking about it differently.